Here is a strange question. Could we be made of tachyons? Could our bodies, our thoughts, the very ground we stand on, be built from particles that only travel faster than light? It sounds like pure science fiction. And maybe it is, but asking questions like this is what science is all about. You take a weird idea and you follow it, you see where it leads. Sometimes it leads to a dead end. Sometimes it leads to a whole new way of looking at the universe. So let's follow this one. Let's really think about it. To start, we need to know what we think we're made of right now. The answer is pretty solid. We are made of atoms. Atoms are made of smaller things. Protons, neutrons, and electrons. Go even smaller and you find quarks, which make up the protons and neutrons. These are the building blocks of our world. We call them matter. They have a few rules they live by. One big rule is that they have mass. Not a lot, but it's there. An electron has a tiny bit of mass. A proton has more. This mass is positive. It's a real number. You can weigh it in a sense. This mass is what gives things inertia. It's what makes it hard to push a car, but easy to push a toy. It's the stuff of the universe. Another big rule comes from a man named Albert Einstein. He told us about the speed of light. He said it's the ultimate speed limit. Nothing with mass can ever reach it. The reason is simple, but also mind-bending. As you push something with mass closer and closer to the speed of light, its mass seems to increase. And it gets heavier and heavier from an outside perspective. To get it to go a little bit faster, you need more energy. Then more, and more. To get it to actually hit the speed of light, you would need an infinite amount of energy. The entire energy of the universe wouldn't be enough to get a single grain of sand to that speed. So, the universe seems divided. There are particles with mass like us. We are stuck in the slow lane. We can never ever reach the speed of light. Let's call our kind of particles tachyons. It's a real term physicists sometimes use. It just means slow ones. Then there are particles with zero mass, like photons, the particles of light. No choice. They must always travel at the speed of light. They can never slow down. So we have the slow stuff and the light speed stuff. Is that it? This is where the math gets interesting. When physicists were playing with Einstein's equations, they noticed something. The equations work just fine if you put in a third kind of particle. A particle that always, under all circumstances, travels faster than light. To make the math work for this particle, you had to give it a strange kind of mass. Not a positive mass, like us, and not zero mass, like a photon. You had to give it an imaginary mass. Now that sounds made up. And it sort of is. In math, an imaginary number is what you get when you take the square root of a negative number. It's a tool, a concept. So an imaginary mass doesn't mean it's not real. It just means its mass squared is a negative number. It's a mathematical quirk that opens up a weird possibility. These hypothetical faster-than-light particles were given a name. Tachyons, from the Greek word tachys, meaning swift. Tachyons would live in a mirror universe to ours, governed by opposite rules. For us, the slow particles, it takes energy to speed up. For a tachyon, it would take energy to slow down. Think about that. A tachyon moving infinitely fast would have zero energy. As you give it more energy, it slows down. But it can never slow down enough to reach the speed of light. The speed of light is a barrier for them, just as it is for us. But they are on the other side. They can't get into our slow world. We can't get into their fast world. The speed of light is the wall between us. So, the first part of our question is answered. There is a theoretical basis for such particles. They aren't just a random sci-fi idea. They fall right out of the same equations that describe our own universe. But that brings us to the real question. Could we be made of them? Could our entire reality be the fast one, not the slow one? At first, the idea seems plausible. If everything around us, including ourselves, was made of tachyons, would we even notice? Well, we would be faster than light, but so would the chair I'm sitting on and the planet I'm on. Our rulers would be made of tachyons. Our clocks would be made of tachyons. Maybe our whole experience of reality would be self-consistent. We would measure the speed of light, and it would seem like a barrier to us, too. A barrier we couldn't slow down to. Maybe we're the tachyons, and we look out at the slow-moving quarks and electrons and call them the strange ones. It's a fun idea to play with, but when you look closer, big problems start to show up. Huge universe-breaking problems. The first and biggest problem is causality, cause and effect. It's the most basic rule of our lives. I push a glass, and then it falls. The push is the cause. The fall is the effect. The cause always comes before the effect. It's not just a good idea, it's the law. It's how time works. The past influences the present, and the present influences the future. not the other way around. Tachyons would smash this law to pieces. Because of the weirdness of relativity, two people moving at different speeds can disagree on the order of events. For slow-moving objects, this is never a problem. We might disagree on exactly how much time has passed, but we will always agree that the glass was pushed before it hit the floor. But with tachyons, this agreement breaks down. If I shot a tachyon beam at a target, I would see the beam leave my gun and then hit the target. Cause, then effect. But someone flying past in a very fast spaceship could see something different. From their point of view, the tachyon would hit the target before it left my gun. They would see the effect happen before the cause. This isn't just a trick of perception. In their frame of reference, time would literally be running backward for the tachyon. Now imagine we could communicate with tachyons. I could send a message back in time. Let's say I send a message to my grandfather telling him not to meet my grandmother. If he gets the message and follows the advice, I would never be born. But if I was never born, I couldn't have sent the message in the first place. This is the famous grandfather paradox. It's a complete breakdown of logic. A universe where cause and effect can be reversed is not a universe where life as we understand it could exist. How could you build anything? How could you learn? How could you even think? Every logical step depends on the one before it. If effects can precede causes, the universe becomes an incoherent mess of paradoxes. So if we were made of tachyons, we would inhabit a universe without a consistent past, present, or future. The very concept of becoming or happening would be meaningless. That doesn't sound like our universe at all. Our universe is built on the steady, reliable arrow of time, moving from cause to effect. This right here is probably the most powerful argument against us being made of tachyons. The simple fact that we can ask the question in a logical sequence seems to prove we aren't. But there's another problem, one that comes from a deeper level of physics called quantum field theory. This theory describes the universe not as a collection of little balls, but as a set of fields that fill all of space. An electron is just a little vibration in the electron field. A photon is a vibration in the electromagnetic field. Everything is a ripple in some underlying field. In this framework, a particle's mass is related to the stability of its field. A field for a normal particle, like an electron, is like a ball sitting at the bottom of a valley. It's stable. It takes a lot of energy to move it. It's happy where it is. This is a stable vacuum state. A field for a tachyon with its imaginary mass is different. It's like a ball balanced perfectly on the very top of a hill. It's incredibly unstable. Any tiny nudge, any random quantum fluctuation, and the ball will roll down the hill. It will fall to a lower, more stable energy state at the bottom of the valley. When this happens, it's a process called tachyon condensation. The unstable tachyonic field collapses. It doesn't want to exist. In this collapse, the tachyons disappear. They were never real, stable particles to begin with. They were just a sign that the field was in a high-energy, unstable state. As the field settles into its new, stable ground state, it often gives rise to new things. Things with real positive mass. This is not just a wild theory. Physicists think something like this actually happened in our universe. The famous Higgs field, which gives mass to many other particles, might have started in an unstable tachyonic state. The universe was balanced on top of that hill. Then it collapsed. It rolled down to the bottom of the valley. This collapse, this tachyon condensation, is what turned the Higgs field on and gave it the properties it has today. So, in modern physics, a tachyon isn't really seen as a particle you could build things out of. It's seen as a symptom of instability. If you find tachyons in your theory, it's a warning sign. It's the universe telling you that your system is about to fall apart and turn into something else. You can't build a house out of dynamite, and you can't build a person out of an unstable field that wants to collapse at the slightest provocation. Matter, the stuff we're made of, has to be stable. It has to be able to stick around for billions of years to form galaxies, stars, planets, and people. Tachyons are the opposite of stable. They are the definition of unstable. Then there are the more practical issues. We have never, ever seen a tachyon. If they existed and could interact with our world even slightly, we should be able to detect them. A particle moving faster than light through a medium, like air or water, should produce a specific kind of light shockwave called Cherenkov radiation. Well, it's like a sonic boom, but for light. We use this effect to detect fast-moving normal particles all the time in our experiments. If tachyons were zipping around, they should be creating these light booms everywhere. We've never seen one that can't be explained by a normal particle moving very fast but still slower than light in a vacuum. The silence is deafening. No unexplained light booms. No particles arriving before they were sent. No signals from the future. The universe looks, for all intents and purposes, like it obeys the law of causality. So the evidence seems overwhelming. We are not made of tachyons. The idea breaks the law of cause and effect. It relies on fundamentally unstable building blocks, and there is zero evidence for them. It seems like a dead end. But let's not give up on the spirit of the question. Let's push it a little further. What if the problems we see are just a failure of our imagination? What if the causality problem isn't a problem for tachyons? Maybe a tachyonic being wouldn't perceive time the way we do. We experience time as a linear flow. It's a stream. But what if, for a tachyonic consciousness, time was more like a landscape? You could see the past and future all at once, just like we can see a whole valley from a mountaintop. The grandfather paradox wouldn't be a paradox because the concepts of before and after wouldn't be fundamental. Everything would just be. In such a universe, free will might not exist. Everything that ever has happened or ever will happen would be a fixed part of this landscape. A being made of tachyons might not decide to do something. They would simply experience their path through the landscape of space-time. It would be a profoundly different kind of existence. Could we even call it life? Could we call it consciousness? I don't know. But it's impossible to say it couldn't exist, just because it's not like our own. And what about the instability problem? Tachyon condensation. The idea that a tachyonic field must collapse. This comes from quantum field theory, our best description of the universe, but our theories are incomplete. We don't have a final theory of everything. What if there's a loophole? What if there's a way for a tachyonic field to be stabilized by some other unknown field or force? What if, in some strange corner of the cosmos, the rules are different? Maybe the universe we see is just one phase of reality. Like water can be ice, liquid, or steam. Maybe there's a tachyonic phase of the universe where things are built from stable faster than light particles. And we live in the tardionic phase, built from stable slower than light particles. If that were true, the two phases might not be able to interact. The speed of light would be an impenetrable wall between our realities. We would be ghosts to them, and they would be ghosts to us. We could live in the same space, at the same time, but be completely unaware of each other. The tachyonic world would be a true dark matter, a dark reality, forever beyond our reach. This is pure speculation, of course. There is no evidence for any of it, but it highlights the core of the question. We are asking if we could be made of tachyons based on the rules of our universe. The causality we experience, the stability we observe, by that standard, the answer is a firm no. But what if we are asking the wrong question? Instead of cooled, we be made of tachyons. Maybe the question should be, what would a universe made of tachyons be like? It would be a place of bizarre energy rules. A particle at rest, for a tachyon, would mean infinite speed. To move it, to give it energy, you would have to slow it down. It would be a place where the concepts of past and future might not exist in a linear way. Information could, in theory, propagate instantly across vast distances. The entire universe might be connected in a way we can't imagine. Could life exist there? Maybe. But it would not be life that evolved through Darwinian competition, where a cause and mutation leads to an effect better survival. The whole logical structure of evolution falls apart without causality, so tachyonic life, if it existed, would have to be created by some other principle. Perhaps it would be a static, unchanging form of consciousness existing across all of time at once. A mind not of thought, but of pure being. It is very hard, maybe impossible, for a brain built on cause and effect to truly imagine existence without it. Every word I am writing, every thought you are having while reading, is a chain of cause and effect. It's the software our minds run on. Trying to think without it is like trying to see without eyes. So let's bring it back to Earth, back to our slow, plodding, tardionic world. The physics we know, the experiments we've done, and the logic we live by all point to the same conclusion. We are made of matter. Matter has positive mass. Matter is stuck on the slow side of the light barrier. Tachyons, if they exist at all, are likely just a temporary, unstable state of a quantum field, not a building block for anything permanent. The idea that we could be made of them is a beautiful, imaginative leap. It forces us to confront the deepest rules of our reality, the nature of time, the flow of causality, the definition of existence. But it's a leap that seems to take us off a cliff. The solid ground of evidence and logic just isn't there to support it. We are creatures of cause and effect. We're born, we live, and we die in that order. We are built from particles that are stable, predictable, and, in the grand scheme of things, incredibly slow. And maybe that's a good thing. A universe where you can't trust that the past is in the past would be a terrifying and chaotic place to live. The idea of tachyons remains a fascinating what if. It's a whisper from the equations of a different kind of reality that might be possible. But all the evidence suggests we don't live there. We live here, in this universe. A universe that seems, for better or for worse, to be made of good, solid, slower than light stuff. The fantasy of being a creature of light speed is alluring, but the reality is that we are creatures of substance. And for now, that's the only reality we have.